So we are on task 2 of outliers, and we're going to work on finding outliers. So what we're going to do here, we see we have a box plot here, and we are going to create um, our box plot using this code right here. So on here, I'm just going to put create a box plot. And on my box plot, what I'm going to do is I'm going to type in snx.boxplot of, and then y equals, and I go shoe of, or shoe, and then brackets, and we want the column gender. So on the y-axis is going to be gender, and then we just go comma x equals, and then we put shoe, and then the brackets of, and we go shoe size. And then I run the cell. And from there, you see we have two outliers on the girls' box plot. We have this outlier of around 13 and one of 30. The one of 30 is probably an error that we made in measurement, and we need to remove that. So what we do is look at how do we find the outliers. So we're going to go back to this 5-number summary and do some calculations here. So on here, we just ran those functions here, but we do find the interquartile range for the girls. And then we do the lower quartiles will be Q1 minus 1.5 times the interquartile range. So the interquartile range, or IQR, is going to equal, if I go back to here, it's going to equal 9 minus 6.5. So 9 minus 6.5, and that equals 2.5. So a lower outlier here would be any number in the data set that is Q1, or 3 minus 1.5 times 2.5. So it would be any number, and when I do that, 3 minus 1.5 times 2.5. So any number below negative 0.75, it's not possible to have a negative shoe size. So there are no values below that. No values are outliers. And then what we do is we check for upper outliers. So we do Q3 plus 1.5 times the IQR. So Q3 here is going to be 9. So we do 9 plus 1.5 times 2.5. So here we go 9 plus 1.5 times 2.5, and that's 12.75. So now we look for numbers in the data set that are above 12.75. So looking at that in the girls, I see we have both 13 and 30. So for that value, we have both 13 and 30.